Okay, in this video we're going to introduce the concept of the volume of a cone. And you see here to the right I have a cone. It's circular with a radius of r on the bottom and comes up to a point here in a circular fashion. You can think of it as little circles just getting smaller, smaller, and smaller. Okay? And that's what a cone is until at the very tip has no radius. Okay? So we're going to talk about the volume. And the volume is always going to be some form of base times height. This thing is not uniformly it's because those circles get smaller and smaller and smaller. It does, so it's not just going to be the base times the height. There's going to be some so because if I just did base times height, what I would get is the volume of if I just did base times height, it would give me the volume of this cylinder here. So there has to be some factor to scale that thing down. And it turns out that the volume is given by, let me see here, 1/3 pi r squared h. Okay, so that pi r squared is the area of this circle down here on the bottom, and then times the height, and then again remember that this would just be the area of the cylinder, and that 1/3 scales it and makes it, the volume of a cylinder, that 1/3 scales it and makes the volume of a cone. So the volume of a cone is 1/3 pi r squared h. So let's look at an example here. Let's say we assume that our radius is 20 feet, and we have a height h equals we don't need that thing there. So h equals, I don't know, let's say 15 feet. That sounds cool. So our volume would be volume equals 1/3 pi, and we're going to approximate pi to 3.14 times r squared. That's going to be my radius times the radius. So my radius is 20 feet, so it's going to be 20 feet times 20 feet. Okay, and then times my height, which is 15 feet. Okay, and here I'm going to take care of everything except the fraction, because I like to I know fractions give people fits. So let's do 1/3 times, and because when we're multiplying, we can multiply in any order we want. We should have learned that in the principles of in the order of operations. So we can multiply any way we want. So I can multiply all my other ones except 1/3 first, and then multiply by 1/3. But I always like to slow down on the fraction. So let's do 3.14 times 20 times 20 times 15. Ooh, we got 18,840. 18,840. And we got feet times feet times feet, cubic feet. Okay? So we got 1/3 times 18,840 cubic feet. And remember, when we multiply by a fraction, we're going to write everything as a fraction and multiply straight across. Top times the top, bottom times the bottom. And I'm going to get here that I have a volume of, let's see, 1 times that's going to be 18,840 divided by 3 times 1 is 3 cubic feet. And let's get the final answer here. 18,840 divided by 3, 6,280. cubic feet. That's my final answer. And again, let's say what that means. That means that if that was a 1 by 1 foot by 1 foot by 1 foot cubic foot, 6,280 of these could fit inside this cone. That's what the volume is. When you're asking for volume, what you're really asking is how many of these can fit in it. And we found that 6,280 cubic feet will fit in a cone with a radius of 20 feet and a height of 15 feet. And that's going to conclude this video on the introduction to the volume of a cone.